Hello, and this is Sunny. Welcome back. Today my topic is IEEE 802.1q standard and VLAN tagging and trunking basics. I will talk about many terminologies such as .1q, VLAN tag, trunk, trunking, trunk port, and access port. I will use one example to show what they are and how they work. IEEE 802.1q, often referred to as .1q, is the networking standard that supports VLANs on the Ethernet network. The standard defines a method of tagging traffic between two switches to tell which traffic belongs to which VLAN. Let's take a look at one simple example. On switch 1, we assign computer A to VLAN 10 and we assign computer B to VLAN 20. On switch 2, we assign computer C to VLAN 10 and computer D to VLAN 20. We can see that both computer A and C belong to VLAN 10 and computer B and D belong to VLAN 20. However, VLANs are local to each switch and VLAN information is not passed between switches. We needed to link these two switches so that computers on the same VLAN could communicate. This link is called a trunk. A trunk, or called 802.1q link or .1q link or simply trunk link, provides VLAN ID for frames traversing between switches. A trunk can be configured between two switches or between a switch and a router. By default, a trunk can carry traffic from all VLANs to and from the switch, but it can be configured to carry only specified VLAN traffic. The process of traversing different VLAN traffic over the trunk is called trunking. The reason that a single link could become a trunk is not because of some special physical keyboard, but simply because of configurations of switch ports on both ends of the link. Trunk port. Trunk port is a Cisco term. In the non-Cisco world, it is called tagged port. Regardless of the name, it means the same thing. A trunk port would add a VLAN tag to an Ethernet frame to indicate what VLAN the frame belongs to. Let's learn one more term, access port. An access port, or untagged port in the non-Cisco world, is a switch port that sends and expects to receive traffic with no VLAN tag. In other words, access port carries traffic only for one VLAN. In summary, to make a different VLAN traffic travel across two switches, we need a trunk. A trunk is created by configuring trunk ports. A trunk port sends and expects to receive tagged traffic. An access port sends or expects to receive untagged traffic. Now let's come back to our example. Suppose computer A wants to talk to computer C on switch 2. It sends a frame. Keep in mind, this frame is normal layer 2 Ethernet frame, nothing special. This frame has a source and destination and etc., but has no information about VLAN 10. I want to emphasize that a computer attached to an access port has no idea about VLAN and even its VLAN belonging. VLAN creation and management are switches' responsibilities. When switch 1 gets the Ethernet frame from computer A, it knows the frame comes from a member of VLAN 10 and goes to another member of VLAN 10 on switch 2. Thus, it needs to send the frame to switch 2 over the trunk. For that purpose, switch 1 does one thing on its trunk port, inserting a VLAN tag into the Ethernet frame. The tag consists of 4 fields. The first field contains the information that triggers Ethernet devices to recognize this is a frame to a VLAN. The second field is used for quality of service, and the third field is 1-bit flag, which is always set to 0 for Ethernet switches. It could be set for token ring networks, but it is rarely used in practice. The last field is VLAN identifier, which can be a number from 1 to 4094. In our example, the tag's VLAN ID is 10. Once the tag is inserted to the Ethernet frame, the new frame is called IEEE 802.1q frame. The process of adding or inserting VLAN tag into the Ethernet frame is called tagging or encapsulation. They mean the same thing. Now is the time to travel across the trunk. We can imagine the trunk is multi-lane highway. Each lane is for each different VLAN traffic. When switch 2 gets the frame on its trunk port, it knows from the tag that the frame should be forwarded to computer C on VLAN 10. Remember, an access port expects untagged frames, thus switch 2 throws away the VLAN tag and delivers the original Ethernet frame to computer C. The whole process of tagging and trunking is done. In this video, we talked about .1q standard and related terminologies, which would help to understand some other related protocols, such as Cisco's VLAN trunking protocol and dynamic trunking protocol. Besides, this basic knowledge would be very helpful to understand two of the most confusing terms in the Cisco world, the default VLAN and the native VLAN, which is my topic in my next video. Thank you very much and see you next time.